Implicit differentiation. Implicit differentiation is a technique that allows you to find the derivative of y without solving for y. And the chain rule must be used whenever the function y is being differentiated. So this is an explicit form, and here is implicit form. So when you're taking the derivative in explicit form, it's pretty straightforward. So the y, we know the derivative of y, we just call y prime for short. And then if we apply our power rules, like right here, we'll get 6x. This derivative will give me a positive 2. And then we all know that that ends up being a 0. So the derivative is now 6x plus 2. Implicit form is just a little bit different because remember, this is a form where you really can't get that y by itself and solve it simply. So we pretty much take the derivative as we go through the problem itself. So going from left to right, this one is easy because that's a power rule and we're taking the derivative with respect to x. So that gives me a 2x. But once I get here, this one is going to require a product rule when I take its derivative. So what I like to do with my product rule is I like to set up my parentheses, and I always use 4 parentheses with a plus sign in the middle, and I just start separating the terms, or the not the terms but the variables that I'll be using. So 5x will be what I put in my first parentheses here, whereas on the other one I'll be using the y. So I have a y here. Now that I have them separated where I want them to go, then I can come in and take the derivative of each. So this derivative will come here. So that derivative is a y prime, but this derivative is a 5. So what I've done is I've applied the product rule within the problem itself of doing the derivative. Now I can continue to the rest of the problem, which is here. That derivative, I'm using a power rule, so that gives me a 2y. But remember, because that y is sitting there, I do need to know what the derivative of y is, which is y prime. And we call that a chain rule. So it's like you link your derivative to the variable that you're taking derivative of. And remember, you apply the chain rule when you're taking a derivative of y, because the problem itself is with respect to x. So as long as it's with respect to x, you can go directly in without having to use a chain rule. But once you run across the y, then you do have to apply the chain rule at that moment in time. Now, this part, the ending of it is very easy because we all know the derivative of any constant is 0. All right, so once you do that much of the problem, always make sure you kind of clean it up and organize it so that it's neat because you're not really done yet. So now that I have everything organized, now that my derivatives have been taken implicitly and I got everything arranged, the next goal is to solve for y prime. So as I go through this line by line, you'll see how it's done. So 2x, I could subtract that to get it to the other side. And that positive 5y, I can subtract it to get it to the other side of that equal sign. So far, I've moved my 2x plus my 5y, and now I have negative 2x minus 5y. Bring down every term that has a y prime, and then that's going to get us a little bit closer to solving for y prime. So as you can see, I have a y prime here and a y prime there. So no different from in algebra when you have to factor out a common factor. The y prime is common between these two terms, which leaves me with a 5x minus 2y in the parentheses, and everything else, I just bring it down, which allows me to divide. I can divide by 5x minus 2y, and over here I can divide by the same thing, 5x minus 2y. And what that leaves me with is a y prime is equal to negative 2x minus 5y over 5x minus 2y. This is my derivative. And depending on what notation you're most comfortable with, sometimes instead of using y prime, you may see books say dy dx. So it just depends on which one looks more comfortable for you. I always default to using y prime, but sometimes I do use dy dx. So that is, you'll know when to be the best time to use either or you can just stick to one.